This assignment was for us to develop an understanding of structural load paths and the design process. To achieve this, our group set out to design different structural members of a domestic shed. We were allocated Group 8 and were given a number of specific design parameters unique to our design. We have prepared a written report that describes our design solution, as well as this video. On the 28th of March, we were visiting the Mawson Lakes University campus, where we were shown a shed, an industrial shed, very similar to the one that we are designing in this project. It was really worthwhile, and I think helped us all visualise exactly what we were designing. We were able to look at the sections and the connections and the bracing and the fly bracing, and also some of the failures that shed had happened due to probably incorrect wind load determinations and some design errors. So it was really worthwhile, and we've attached some photos of that visit. Before commencing with the design of our shed, we needed to determine the wind load by looking at a few different factors. The first one was wind speed region. This was given to us as part of our assignment. Our shed was classed as being in a non-cyclonic area, wind region B. The next thing we looked at was the terrain category, which was TC1, which is described as a very open or exposed terrain with few or no obstructions. The topographic classification was T3. This determines the wind effect of a building due to its location, for example on a hill or a ridge. Our shed was classed as being partially shielded, meaning that there were at least 2.5 houses or sheds per hectare. Combining all of the above, we were given a wind class of N5 and given parameters to determine serviceability and ultimate limit state, which helped us design the rest of our shed. Once we knew the inward and outward pressures from determining the wind load our shed would be subjected to, we looked at purlin design. First, we selected the roof board, considering slope, weight, pitch, rib depth, and visual aspects, determining that trim deck 0.42 was the best choice. We also selected purlin CZ20019 and determined its spacing, which was 1400. We were then able to work out the total dead load and the dead load of the sheeting and purlin self-weight. Through combining of loads and some mathematics, we were able to determine our chosen sections were both able to be used for our shed. We then moved on to girt design. To design the girts, the wall cladding profile was selected first, and we chose trim deck 0.48. We then considered the cladding weight, installation, and the fibrous plasterboard to determine the total dead load, and used the wind load from the previous section to ensure that our girts were designed properly for the shed. We then moved on to bracing design. The members of our group found that this part of the assignment was probably the hardest portion to work out. We started with determining the net pressure coefficients using the table in the code. We then determined wind pressure and suction calculations, worked out the layout of our bracing design, removed compression members, which left us with the members that we needed to determine the forces, which we then did, and then we selected the appropriate section for each of the members. We found this a little bit confusing to work out the correct layout given the wind direction, so we gave it our best go. By carrying out this assignment to design different structural members of a domestic shed and describe the design solutions that we've come up with has certainly given us a better understanding of structural load paths and the design process. It's been a pretty good investigative experience, and research and findings have led us to gain a better understanding of how each member of the shed works. And I think designing each member individually has certainly given us information that we'll take with us into our careers in the industry. As a group, we worked pretty well together. Just a few days ago, I think it was the 25th of May, we lost our team member Tom, so myself and Abdul have been left with quite a heavy workload to finish in the last week, so I think it's definitely been a learning curve on time pressure as well. So I think overall, though, we got majority of the assignment done, and we're happy with the end result. Again, great assignment. I think the knowledge that we've gained from this will certainly help us in our careers. We now invite you to press play on the video below. It gives a quick overview on the construction of a industrial shed very similar to the one that we just designed, with bracing, purlins, rafters and girts. We found this video quite informative during the design solutions, just being able to visualize again what we were designing and how it all works together.